Hey, Katie.
Hi.
All right, hope you're enjoying these videos as much as the kids love me videoing here. Okay. Okay, so chapter 6, again, it's going to seem like chapter 5 because it's very similar. But trust me, you know, it's actually a little bit easier than chapter 5 maybe, but it kind of makes more sense, I think, than chapter 5. So applications of the derivative. We're going to actually be using the derivative to answer some questions. And today we're looking at absolute extrema. So what kind of extrema were we looking at last chapter? Relative. So absolute extrema is kind of just what it sounds like. It is the largest and smallest possible values. So we're not just looking at relative values. We're looking at the largest and smallest possible values. Okay. And the difference here is now we're going to be looking, for today at least, we're going to be looking at just a closed interval. So this rule looks very much like the rule we looked at for relative mins and maxes, in that if a function is defined on an interval that contains some c, f of c is the absolute max if is the absolute max if f of c is greater than f of x for all the other x's. And again, it's that greater than that makes it a max, and is a relative min if f of c is less than all the other function values for all the other x's. Okay, so that looks very similar to what we did with relative mins and maxes. The difference is you can see it on the graph. If I show you these graphs, and again, they've got endpoints. This one doesn't have arrows, right? So where is the absolute max happening for that function? At 3, right? So at 3, what do we have a max of? So here's 3. Let's call it 4, okay? And where are we having an absolute max anywhere else at 4? -2 also, right? So the absolute max for this function, again, which means the highest point for the function, is actually occurring twice, right? At 3 and -2. Make it smaller. So it's happening at both 3 and -2, but the actual greatest, oh, hang on. So stop that. No, let's back up on that. Okay, so no, scratch all that, okay? We're looking at where's the absolute highest point, and it occurs way over here, right, at 10, right? This is where the highest y value hits. And again, because there's no arrows, we can say that it stops right here, right? And so the highest value it achieves is 1, 2, 3, 4, 5, 6, 7, right? So this point right here is at 7. So the max occurs at 10 of 7. Okay, sorry about that. Where's the absolute min? Where's the absolute lowest it gets? At 6. And what is the lowest value the function ever occurs at or gets to? Let's say -3. So at 6 of -3. Okay, so now we're not so concerned about these relative. Like this would be a relative maxes, right? -2 and at 3. Those are relative maxes because if you were looking at just a piece of the function at a time, there would be maxes occurring, but the absolute max doesn't occur till 10, right? On this next one, so I knew there was one that hit 2. What is the absolute max over here? Yeah, -3 and 1, and it's occurring at, let's say, 3.5. Does that make sense? So if we said this is 3.5, and it's occurring at 1 and -3. So we have absolute max at -3 and 1 of 3.5. And what about our absolute min? 6. 6, and it is -3, right? At 6. And again, I apologize about these graphs. I should have given you all better graphs there. Okay, so there again, we're not worried about like this little relative min here in the middle or this endpoint that goes lower. Those are only relative mins. We're trying to find the absolute mins and maxes. Okay, and the difference is, especially for today, we're going to be using closed intervals. So intervals with endpoints. Okay, so we had to take into account those endpoints. So just a reminder, absolute extrema, or the mins and the maxes, are actually the y values that occur at an x value, right? So reminder that the absolute max on this is 7. It happened at 10. The absolute min is -3. It happened at 6. Okay, so just to keep that terminology going. So the extreme value theorem, again, so when we're talking about absolute value or extreme value, absolute extrema, a function f that is continuous on a closed interval, again, because we're going to have endpoints, will have an absolute max and an absolute min on the interval. Okay, so we're always going to have one. If we have a closed interval like this, we're always going to be able to find absolute max or min. And they're going to happen at the critical points or the endpoints. Okay, so the steps we're going to use to find these, again, are going to sound just like last chapter. We find the critical points in the interval, but instead of having to find out whether they're increasing or decreasing, we're just going to find the critical points and find the y values for all of those critical points, and find the y values for the endpoints, and select the highest or lowest. Okay, so there's not so much intermediate work of plugging into derivatives. We're going to take the derivative to find the critical points, but we're just going to plug it into the function to find the absolute values, absolute extrema. Okay, so let's try an example. So again, this notation here is just telling us we're on an interval from -3 to 0, right? And the fact that it's less than x greater than or equal to and less than or equal to means that those -3 and 0 are included, right? So if we were to graph them, they would be filled in points. So we want to find, so we know the absolute highest or lowest point is going to be either -3 or 0 or one of the critical numbers. So to find a critical number, we do what? Take the derivative. So we get 6x squared plus 6x minus 12. Now we need to set it equal to 0. So how can we factor? Take out a 6. X squared plus x minus 2. Factor that, we keep the 6, right? And we get what? X plus 2 minus 1. So our critical numbers are -2 and 1. Okay, so are both negative. So again, we're only interested in the absolute max and mins in this interval, right? So, and we're saying they could occur at -2 or 1. Well, is -2 in this interval? Yeah. Is 1? No, so we don't care about 1, okay? Because again, we're only trying to find, if we were to graph this, what's the absolute max and min from 0 to -3? So we add -2 to our number line, but we don't care about 1. Okay? Now, if we know that the absolute min and max occurs at either -3, -2, or 0, again, we don't care whether it's increasing or decreasing. We just want to find out, well, what's the maximum value it gets at these 3 points, and what's the min? So we skip over all that plugging into the derivative, and we're just going to plug it into the original function. Okay, so we want to find f of -3, f of -2, and f of 0. So actually, after the question I just handed back, I want everybody to get out your calculators and plug in those values. Okay, so we got f of -3 is 2, f of -2 is 13, f of 0 is -7. Everybody agree with those numbers? Okay, so now if we say f of -3 is 2, f of negative 2 is 13. 0 is negative 7. So just looking at these numbers now, what is the highest? Negative 2 of 13, right? So we have a max, the absolute highest this function gets. We have a max at negative 2 of 13. And what's the lowest? Negative 7, right? So we have a min at 0 of negative 7. Okay, does that make sense? So we're kind of taking out, since we're not looking for relative mins and max, we don't care, you know, where we might find a max. It's not the absolute max, so we can take out all of that, substituting into the derivative. Okay. All right, let's try another one. Again, this 3 should be over. Yeah, that should be 1/3, extra third. So again, this is just more notation of what it could look like, right? If we're only concerned about x greater than or equal to 0 or less than or equal to 6. So we've got 0 to 6, and we don't care about anything that falls outside. So we know we're going to check 0 and 6, but we also need to see any critical numbers, right? So we're going to take the derivative. So 3 times 1/3 is going to give us 1, x squared minus 9. Everybody agree with that? And then we set it equal to 0, and we get x equals what? Plus or minus 3. Does that make sense? So which one are we worried about? Positive 3, right? We don't care. That's the good part about this. We don't care about negative 3. Yes, absolutely. I'm just giving you a break right now. Okay. All right. Okay, so there again, we know that the relative absolute maximum is happening in one of these numbers. Okay, that's what the theorems tell us. So we just have to find out which one. So we want to find f of 0, f of 3, and f of 6. So everybody try that. You guys agree with 5, negative 13, and 23? Everybody good? So again, 0 is a 5, 3 is a negative 13, and 6 is a 23. So where's our absolute min? At 3 of negative 13. And our max is 6 at 6. Okay, so not so bad so far, huh? Yes. It's a test. Good job. I really don't want this on video, but anyway. All right, questions about that? Okay, too many numbers running through my head. All right, let's try another one. So again, now we've got the system down, but we're going to practice some harder derivatives, right? Get some practice in. Okay, so now we're only worried about numbers from 1 to 10. So we need to check 1 and 10 and also any critical numbers. So again, move that x belongs underneath that 9. So we want to rewrite that, right? I'm not taking a derivative yet, but I'm going to write that as x plus 9 what? X to the negative 1, right? Several of you messed that up on the test, so be careful about that. So now I take the derivative. And I get 1 minus 9x to the negative 2. Everybody agree with that? So now that becomes 1 minus, so a lot of you came up and asked me during the quest whether you could keep it like that or not. And you definitely could keep it with the negative 2 to take the next derivative. But when it comes time to solving, it's really better you want to rewrite that and bring that down. Because now, how do we want to solve that? Okay, set it equal to 0. What do we want to do? We eventually want to get that x squared by itself. What's that, Catherine? You could take the 1 to the other side, or what I'm going to do is it's a little bit easier because I'm going to add this to the other side. It just makes everything positive. Okay, we get the same answer if we subtracted the 1, but I feel like negatives, kind of mess up things at times. So I'm going to add the 9x squared to both sides. And I get 1 equals 9 over x squared. Now, how do I get the x squared by itself? I don't like it on the bottom. How can I bring it up? Multiply top and bottom, right? Because, again, if you do it on one side, you have to do the other. So multiplying it by both sides, it cancels out on one side, and I get x squared equals 9. And then x equals plus or minus 3, right? I'm taking the square root of both sides. And again, this becomes, we're going to do this a lot in this chapter. Anytime you're solving for x, like taking the square root of something, then you're going to get a plus or minus, right? Because positive 3 times 3 would give you positive 9, and negative 3 times negative 3 would give you 9. So again, which number are we worried about? Plus 3. So now we just need f of 1, f of 3, and f of 10. So again, I'm just going to plug these in by hand because sometimes that's even easier. So if I plug in a 1 into my original function, I get 1 plus 9 over 1 gives me what? 10, right? If I plug in 3, I get 3 plus 9 over 3, which gives me what? 6, right? 9 over 3 is 3. F of 10, I get 10 plus 9 over 10 gives me 10 and 9/10, or 10.9, or 109 over 10. But yeah, 10.9 would make it a little easier to compare, right? So where is our absolute min happening? At 3 of 6. And our absolute max at 10 of 10.9. Okay, questions so far? All right, let's try another one. All right, let's try this one. So again, we're only interested in 2 to 12. When I take the derivative, what are we going to have to use for the derivative here? Quotient rule, right? We're going to get there eventually, right? Okay, derivative of the top is a 1 times the bottom, 7 minus x, minus, what's the derivative of the bottom? Negative 1 times the top, which is x, all over the bottom squared. Everybody good with that? Okay, now how do we, so the 7 minus x we keep, right? That 1 doesn't do anything. Negative minus a negative 1x gives us what? Positive x, right? Over 7 minus x squared. So that simplifies to what? 7 over 7 minus x squared. Now, we set that equal to 0, and how do we solve it? multiply top and bottom by what? Palmer? The denominator, right? So 7 minus x squared. So it cancels out over here. I get 7 equals 0. So do we have any critical numbers? So are we done? No, because we can still do what? We can still check 2 and 12, okay? So even though we don't, because we know our theorem said there's always going to be a max or a min, so sometimes it's going to be the endpoints. So f of 2, and actually these are harder on the derivatives, but they're easier to plug in, right? So 2 over 7 minus 2 gives me 2/5. Agree with that? F of 12 gives me 12 over 7 minus 12 gives me 12 over -5. So negative 12/5. So my max is at 2. My min is at 12. Got 2 of 2 over 5 and a min at 12 of negative 12 over 5. Okay, questions about that? All right. Okay, this next one, I want you guys to take the derivative and we'll work out the critical numbers or the absolute maximums after you find the critical numbers. Okay? Losing it. Okay. All right, so if you took the derivative and solved, did everybody get down to this for the derivative? So 2 minus x squared over x squared plus 2 squared. Or can you like cancel it? Okay, because of this negative 2x squared. Good question. In other words, this is not, you can't just like pick out this part and say we can cancel, because you have to combine all this first. It would have to be a whole family that you could cancel it. Okay, so yeah, good question, but don't do that. So yeah, if we had combined and somehow this had gone away, then we could have canceled one. Okay. Okay, so we got down to here, and then sub equal to 0. So again, we're going to multiply both top and bottom by the denominator. We get here. How do we solve 2 minus x squared equals 0? What can we do, Molly? Yeah, we could go ahead and subtract 2, or again, we could add. So we get negative x squared equals negative 2, and then we divide by negative 1. Again, I would have just added the x squared over, but that's fine. So we get positive x squared equals positive 2. And now what do we do? Okay. Take the square root of both sides, right, to undo the square. So x equals plus or minus radical 2. Okay, so again, your numbers don't always have to be good integers, right? So plus or minus radical 2, which one are we worried about, or which one do we need to use? Positive radical 2. We don't need negative radical 2. Okay, makes sense? Again, just different variations. So now we know our absolute min and max is going to happen at either 0 or radical 2 or 4. Okay, and we can plug those in. So be careful. F of x or f of 0, you might think, oh, it's going to be 0, right? But it's actually, I mean, it's going to be 0 on the bottom. Undefined, but again, we get 0 over 0 plus 2. So 0 over 2 is what? 0, right? We plug in a radical 2, we get radical 2 over, what is radical 2 squared? 2, right? Radical 2 times radical 2 just gives us a 2, plus 2 gives us radical 2 over 4. And then radical 4 gives, gives us 4 times 4 squared plus 2. Is that right? Gives us 4 over 18. Bear with me now. And that becomes what? 2 over 9. So does anybody know what's greater, radical 2 over 4 or 2 9? So let's check it out. Put them on your calculator, right? And we get radical 2 over 4. So this is where decimals definitely come in handy, right? What's that? It's that one. Radical 2 over 4. So that gives us 0.35 and 2/9. Yeah, it gives us 0.22. So we've got at radical 2, we've got 0.35. And at 4, we have 0.22. So where's our max? And where's our min? Right. Yes. Everybody agree with that? So this is our max. And again, 0 is less than 0.22. So that's our min. So we have a max at radical 2 of, again, you can either use the decimal form or the fraction form. And a min at 0 of 0. Okay? I guess so far? A little bit easier than last chapter? All right. How many more we got? Let's see. Oh, last one. Wow. Okay, I'm not going too fast for you guys, are you? Okay, let's get that. Okay. All right, so you guys, I'm going to let you all go and take this derivative on your own. Let's see how you do. Okay, so questions about this derivative, what I've done so far? Molly. Again, that is all the same thing. Does that make sense? So I can write that like this. Is the same as 8x to the 5/3 over 3. Does that answer your question? Okay. So yeah, don't let that mess you up. Everybody okay with this? So I brought down the 2/3, 16 times 2 is 32/3. Subtract 1, x to the negative 1/3. And again, that when that x comes down, it's just joining the denominator of 3. Okay. Now, a couple ways to solve this one. When you set equal to 0, we could, what could we do? Come on. We could get common denominator, and I know how you all love getting common denominators. There's actually an easier way to do it. Because we're trying to set it equal to 0, what can we do? Well, we could multiply everything by the common denominator and clean it out. But there's even an easier way to do it. It's similar to how we've been solving equations. We can get this on the other side, okay, and then get rid of that as a denominator. All right, and you'll see how that goes. This only works because we only have the 2 terms, okay? And this is common for the problems you're going to see in this chapter. That's why I want to show you all this easier way. So I'm going to add 32, 3 to the over 3, x to the 1/3 to both sides. And I get 8 x to the 5/3 over 3 equals 32, 3x to the 1/3. Now, if I want to get rid of those, if I want to get x by itself, right, then I need to get rid of it down here. So I can multiply just like I just did, 3x to the 1/3, top and bottom. It's basically the same as getting a common denominator, only we brought it over to the other side when we're doing it. So these cancel out, right? What happens over here? The threes will cancel. And now, magic question today. What is x to the 1/3 times x to the 5/3? X squared y. Right, because we're adding exponents, right? So 1/3 plus 5/3 gives us 6/3, which gives us 2. Now, I was like, no way. Still? Yeah, do you see that though? Now, again, it's the same thing as on your test, where it's like something to the 1/2 times something to the 1/2 equals something to the first, right? So this becomes 8x squared equals 32. And now it becomes a little easier. What do? Divide by 8. X squared equals 4. So x equals so minus 2. And which one do we care about? Yep, just the 2, right? Just the positive. So now we just need f at -1, f at 2, and f at 8. All right, and I'm going to talk through this a little bit. You can do it on your calculator, but I also want you all to have some kind of intuition about it. At least this first one. So what is... Oh, shoot. So -1, cube root of -1 is going to be what? -1, right? Because, again, you can take the cube root of a negative number. If I take -1 to the 8th power, I'm going to get what? +1, right? So in the end, it's a +1. Okay. I also could have done it the other way. -1 to the 8th power is going to give me +1. Cube root of +1 is going to be +1. Okay. And then, so -1 to the 2/3 is going to be, again, +1, right? Because cube root of -1 is -1, but squaring it is +1. So that becomes -16. So -1 is -15. Now 2, I'm going to plug it on my calculator. So f at 2 became -19.05. Everybody agree with that? And then 8 was, actually we could have done that by hand, right? Because no good cube root of 8. 192. Did I get 192? So our absolute max is what? At 8 of 192. Our absolute min is at 2 of -1905. And then at 2 of -1905.